pioneers would have reached the southern tip of South America only 700 years after crossing the Canadian border. Those postulated rates of spread and of population increase are very low compared with actual known rates for peoples occupying previously uninhabited or sparsely inhabited lands. Hence the Americas were probably fully occupied by hunter-gatherers within a few centuries of the arrival of the first colonists. Second, could a large part of the 5,000-year lag have represented the time that the first Americans required to become familiar with the new local plant species, animal species, and rock sources that they encountered? If we can again reason by analogy with New Guinean and Polynesian hunter-gatherers, and farmers occupying previously unfamiliar environments, such as Maori colonists of New Zealand or Tudor colonists of New Guinea's Karimu Basin, the colonists probably discovered the best rock sources and learned to distinguish useful from poisonous wild plants and animals in much less than a century. Third, what about Eurasians' head start in developing locally appropriate technology? The early farmers of the Fertile Crescent and China were heirs to the technology that behaviorally modern Homo sapiens had been developing to exploit local resources in those areas for tens of thousands of years. For instance, the stone sickles, underground storage pits, and other technology that hunter-gatherers of the Fertile Crescent had been evolving to utilize wild cereals were available to the first cereal farmers of the Fertile Crescent. Thick tundra. They had to invent for themselves the equipment suitable to each new habitat they encountered. That technology lag may have contributed significantly to the delay in Native American developments. An even more obvious factor behind the delay was the wild animals and plants available for domestication. As I discussed in Chapter 6, when hunter-gatherers adopt food production, it is not because they foresee the potential benefits awaiting their remote descendants, but because incipient food production begins to offer advantages over the hunter-gatherer lifestyle. Early food production was less competitive with hunting-gathering in the Americas than in the Fertile Crescent or China, partly owing to the Americas' virtual lack of domesticable wild mammals. Hence early American farmers remained dependent on wild animals for animal protein and necessarily remained part-time hunter-gatherers. Whereas in both the Fertile Crescent and China animal domestication followed plant domestication very closely in time to create a food-producing package that quickly won out over hunting-gathering. In addition, Eurasian domestic animals made Eurasian agriculture itself more competitive by providing fertilizer, and eventually by drawing plows. Features of American wild plants also contributed to the lesser competitiveness of Native American food production. That conclusion is clearest for the eastern United States, where less than a dozen crops were domesticated, including small-seeded grains but no large-seeded grains, pulses, fiber crops, or cultivated fruit or nut trees. It is also clear for Mesoamerica's staple grain of corn, which spread to become a dominant crop elsewhere in the Americas as well. Whereas the Fertile Crescent's wild wheat and barley evolved into crops with minimal changes and within a few centuries, wild teosinte may have required several thousand years to evolve into corn, having to undergo drastic changes in its reproductive biology and energy allocation to seed production. Loss of the seed's rock-hard casings, and an enormous increase in cob size. As a result, even if one accepts the recently postulated later dates for the onset of Native American plant domestication, about 1,500 or 2,000 years would have elapsed between that onset and widespread year-round villages in Mesoamerica, the inland Andes, and the eastern United States. Native American farming served for a long time just as a small supplement to food acquisition by hunting-gathering, and supported only a sparse population. If one accepts the traditional, earlier dates for the onset of American plant domestication, then 5,000 years instead of 1,500 or 2,000 years elapsed before food production supported villages. In contrast, villages were closely associated in time. Hemispheres colliding. With the rise of food production in much of Eurasia, the hunter-gatherer lifestyle itself was sufficiently productive to support villages even before the adoption of agriculture. In parts of both hemispheres, such as Japan and the Fertile Crescent in the Old World, and coastal Ecuador and Amazonia in the New World. The limitations imposed by locally available domesticates in the New World are well illustrated by the transformations of Native American societies themselves when other crops or animals arrived, whether from elsewhere in the Americas or from Eurasia. Examples include the effects of corn's arrival in the eastern United States and Amazonia, the llama's adoption in the northern Andes after its domestication to the south, and the horse's appearance in many parts of North and South America. In addition to Eurasia's head start and wild animal and plant species, developments in Eurasia were also accelerated by the easier diffusion of animals, plants, ideas, technology, and people in Eurasia than in the Americas, as a result of several sets of geographic and ecological factors. Eurasia's east-west major axis, unlike the Americas' north-south major axis, permitted diffusion without change in latitude and associated environmental variables. In contrast to Eurasia's consistent east-west breadth, the New World was constricted over the whole length of Central America and especially at Panama. Not least, the Americas were more fragmented by areas unsuitable for food production or for dense human populations. These ecological barriers included the rainforests of the Panamanian Isthmus separating Mesoamerican societies from Andean and Amazonian societies, the deserts of northern Mexico separating Mesoamerica from U.S. southwestern and southeastern societies, dry areas of Texas separating the U.S. Southwest from the Southeast, and the deserts and high mountains fencing off U.S. Pacific coast areas that would otherwise have been suitable for food production. As a result, there was no diffusion of domestic animals, writing, or political entities, and limited or slow diffusion of crops and technology between the New World centers of Mesoamerica, the eastern United States, and the Andes and Amazonia. Some specific consequences of these barriers within the Americas deserve mention. Food production never diffused from the U.S. Southwest and Mississippi Valley to the modern American breadbaskets of California and Oregon, where Native American societies remained hunter-gatherers merely because they lacked appropriate domesticates. Tick turkey of Mesoamerica never made it to South America or the eastern United States. Mesoamerican corn and beans took 3,000 and 4,000 years, respectively, to cover the 700 miles from Mexico's farmlands to the eastern U.S. farmlands. After corn's arrival in the eastern United States, several centuries more passed before the development of a corn variety productive in North American climates triggered the Mississippian emergence. Corn, beans, and squash may have taken several thousand years to spread from Mesoamerica to the U.S. Southwest, while Fertile Crescent crops spread west and east sufficiently fast to preempt independent domestication of the same species, or else domestication of closely related species elsewhere. The barriers within the Americas gave rise to many such parallel domestications of crops. As striking as these effects of barriers on crop and livestock diffusion are the effects on other features of human societies. Alphabets of ultimately Eastern Mediterranean origin spread throughout all complex societies of Eurasia, from England to Indonesia, except for areas of East Asia where derivatives of the Chinese writing system took hold. In contrast, the New World's sole writing systems, those of Mesoamerica, never spread to the complex Andean and Eastern U.S. societies that might have adopted them. The wheels invented in Mesoamerica as parts of toys never met the llamas domesticated in the Andes to generate wheeled transport for the New World. From east to west in the Old World, the Macedonian Empire and the Roman Empire both spanned 3,000 miles, the Mongol Empire 6,000 miles. But the empires and states of Mesoamerica had no political relations with, and apparently never even heard of, the chiefdoms of the eastern United States 700 miles to the north or the empires, and states of the Andes 1,200 miles to the south. The greater geographic fragmentation of the Americas compared with Eurasia is also reflected in distributions of languages. Linguists agree in grouping all but a few Eurasian languages into about a dozen language families, each consisting of up to several hundred related languages. For example, the Indo-European language family, which includes English as well as French, Russian, Greek, and Hindi, comprises about 144 languages. 27. Quite a few of those families occupy large, contiguous areas. In the case of Indo-European, the area encompassing most of Europe east through much of Western Asia to India. Linguistic, historical, and archaeological evidence combines to make clear that each of these large, contiguous distributions stems from a historical expansion of an ancestral language, followed by subsequent local linguistic differentiation to form a family of related languages. Most such expansions appear to be attributable to the advantages that speakers of the ancestral language, belonging to food-producing societies, held. Hemispheres colliding. Table 18.2, Language expansions in the Old World. Over hunter-gatherers. We already discussed such historical expansions in chapters 16 and 17 for the Sino-Tibetan, Austronesian, and other East Asian language families. Among major expansions of the last millennium are those that carried Indo-European languages from Europe to the Americas and Australia, the Russian language from Eastern Europe across Siberia, and Turkish from Central Asia westward to Turkey. With the exception of the Eskimo, Aleut language family of the American Arctic and the Nadine language family of Alaska, northwestern Canada, and the U.S. Southwest, the Americas lack examples of large-scale language expansions widely accepted by linguists. Most linguists specializing in Native American languages do not discern large, clear-cut groupings other than Eskimo, Aleut, and Nadine. At most, they consider the evidence sufficient only to group other Native American languages into 100 or more language groups, or isolated languages. A controversial minority view is that of the linguist Joseph Greenberg, who groups all Native American languages other than Eskimo, Aleut, and Nadine languages into a single large family, termed Amerind, with about a dozen subfamilies. Some of Greenberg's subfamilies, and some groupings recognized by more traditional linguists, may turn out to be legacies of New World population expansions driven in part by food production. These legacies may include the Uto-Aztecan languages of Mesoamerica and the western United States, the Oto-Manguean languages of Mesoamerica, the Natchez-Muscogene languages of the U.S. Southeast, and the Arawak languages of the West Indies. But the difficulties that linguists have in agreeing on groupings of Native American languages reflect the difficulties that complex Native American societies themselves faced in expanding within the New World. Had any food-producing Native American peoples succeeded in spreading far with their crops and livestock and rapidly replacing hunter-gatherers over a large area, they would have left legacies of easily recognized language families, as in Eurasia. And the relationships of Native American languages would not be so controversial. Thus, we have identified three sets of ultimate factors that tip the advantage to European invaders of the Americas. Eurasia's long head start on human settlement, its more effective food production, resulting from greater availability of domesticable wild plants and especially of animals, and its less formidable geographic and ecological barriers to intracontinental diffusion. A fourth, more speculative ultimate factor is suggested by some puzzling non-inventions in the Americas, the non-inventions of writing and wheels in complex Andean societies. Despite a time depth of those societies approximately equal to that of complex Mesoamerican societies that did make those inventions, and wheels' confinement to toys and their eventual disappearance in Mesoamerica, where they could presumably have been useful in human-powered wheelbarrows. Hemispheres colliding. Figure 18.1, the Norse expansion from Norway across the North Atlantic, with dates or approximate dates when each area was reached. NAL Australia, Japan, Polynesian Islands, and the American Arctic. Of course, the Americas in aggregate are anything but small, their combined area is fully 76% that of Eurasia, and their human population as of AD 1492 was probably also a large fraction of Eurasia's. But the Americas, as we have seen, are broken up into islands of societies with tenuous connections to each other. Perhaps the histories of Native American wheels and writing exemplify the principles illustrated in a more extreme form by true island societies. After at least 13,000 years of separate developments, advanced American and Eurasian societies finally collided within the last 1,000 years. Until then, the sole contacts between human societies of the Old and the New Worlds had involved the hunter-gatherers, on opposite sides of the Bering Strait. There were no Native American attempts to colonize Eurasia, except at the 321 Bering Strait, where a small population of Inuit derived from Alaska established itself across the strait on the opposite Siberian coast. The first documented Eurasian attempt to colonize the Americas was by the Norse at Arctic and subarctic latitudes. Norse from Norway colonized Iceland in AD 874, then Norse from Iceland colonized Greenland in AD 986, and finally Norse from Greenland repeatedly visited the northeastern coast of North America between about AD 1000 and 1350.